bit about channelization, how readily that can be done photonically. This should be more generally labeled frequency conversion. In my earlier diagram, it was definitely down conversion we wanted to do, but as this diagram shows, photonics is very well set up to do frequency conversion in general. If I cascade two modulators, remember modulators are just mixers, I can take my optical source, modulate it with some LO frequency, modulate, and that will look like this in the optical spectrum. Here's my optical carrier, where it's really very far from DC, so that's what this cut mark means. My LO modulates that, and then my RF modulates this combination to produce this very complicated thing. But now, all I'm using, the purple doesn't differ from the blue, except in that to point out that this is the portion of the blue that ended up near the optical carrier. So if I put a bandpass filter around that, that's all I'll keep, and the photodetector then will come out at this IF frequency. So if this was 10 gigahertz and this was 11 to 11.5 gigahertz, this would be 1 to 1.5 gigahertz, for instance. It's a very straightforward way to do this. In fact, you might not even need the optical filter if down conversion is what you're doing, because you can use a slow enough detector that it rejects on its own everything higher than more than this distance away from the optical carrier. So there's so many clever arrangements of this stuff, and if you read the literature, photonics is so well set up to do this type of functioning. So I've stepped through all these boxes.
Excuse me.
Yes.
You might also like to share whether these technologies are used commercially or in any military products. I mean, like down conversion. Do people use it?
We sell systems to the DoD in which that is a step in the chain.
I see.
Because the systems part of our name is true. We tend to sell whole systems. The photonics part of our name isn't entirely true, and that sometimes what we sell doesn't have any photonics in it. But as it turns out, it's hard to be prophetic when you name your company. Yeah, it tends to be something that you do as a step and not its own product. That's a very good question. Whereas, interestingly, we also sell to people making systems. We haven't ever sold, we've often just sold this link, and now we're selling this box as its own piece to go into somebody else's system. We've never sold just this down converting piece.
So there is no standalone product?
No, not that I know of. That's a really good question. So this is back to my system diagram. The other convention I tend to use, and you see it sometimes, I think it's picked, I don't know who stole it from whom, is to use thick lines for RF components and thinner lines for the optical components like the photodetector and modulator. I just showed you notionally how one might do a lot of these steps photonically, and so that would turn into this. And the other convention often is that since often what connects one photonic component to another is fiber, you kind of show that notionally with these little loops hanging down from the line. You'll see that a lot in papers if you go and read the papers, but everybody kind of has their own style, and it makes it interesting to go read the papers. I actually kind of want to enforce one like standard convention because I think that would be very helpful. It doesn't have to be mine, but but I'd love to get everybody together and agree on it.
Excuse me, I have
yes.
one more question.
Yes.
In all your slides, you have external modulation.
I have. I'm sorry.
External modulation. You have that.
I do in all of those. I do, but I'm gonna get to other ways to do it. Yeah. And you'll see why I've chosen to do that, because I think there is a reason to prefer external modulation, but it's not the only thing, it's not the only game in town, and as you'll see, I'm going to get to that.
Okay.
Thank you for the question. So here's things you can do if you've got microwave photonics as a tool, but how do you make a good microwave photonics system? It really starts with this basic photonic link, which at a minimum is a laser and modulator, which as you'll see can be the same component in a direct modulation link that you're referring to. I think, and you need a photodetector and some optical medium in between. If you can't get that working well, then none of the rest of it's going to do well for you. And more than that, if you can't get that working well without an amplifier, the word I shudder to use, but there's no better way to say it. If you can't get that working well without an RF preamp, for instance, to get the noise figure down low, you're probably not going to sell your photonic links, because they have very good dynamic range, rivaling that of an LNA, but they tend to have large noise figure unless you really know what you're doing to get it low. And therefore, to get the noise figure of the system low, you tend to have to preamplify, and then the dynamic range comes down for that cascade, and it's no longer very attractive. I'm going to mention a lot more about that. This wasn't your only shot at following what I mean. Another reason not to want to get the amplifier kind of out of the picture, is that if you need an amplifier, you're going to negate the ability to do a bunch of the things I said. Here's an example of that. These are those two architectures I spent a lot of time on earlier, the suppression of co-site interference and the suppression of, we can call it self-site interference or simultaneous transmit receive from the same antenna. You can see where an amplifier kind of spoils both of these. The whole purpose of doing interference cancellation here was to cancel interference before you reach a nonlinear component. So if you have to go through amps before you get to the canceller, it's too late to do the canceling. The big signals have saturated the amps and prevented your system from being sensitive to the green signal, the small signal that you want to receive. So you need to get these amps out of there, so the link without the amps has to perform well on its own. Here, the presence of the amp negates the ability to get the transmit signal to the antenna at all. So again, why are you doing this? So that's just an example of why we need good performing photonic links. Here's a diagram of a basic link, and as the gentleman said, I always seem to show external modulation links. Here I'm being as general as I know how to be. You have to have a source, you have to have a modulator. To be the most general, you have to have both those functions. Those don't have to be two separate devices, which I think is what he was alluding to, and I'll get to that. In fact, on this slide I get to it. And then you need photodetection and an optical medium. Photodetectors, I'm sure there's other types, but the most common type, because it's a very, very well-performing device, is the PIN photodiode detector. It's got a very linear output current in terms of the relationship between the output current and the input optical intensity or power. But that's all it can respond to is changes in optical intensity or modulation of the optical intensity. Intensity is this quantity inside these squared brackets. Now to get that, to modulate the optical intensity, I can either modulate the amplitude, and I can do that either directly or externally. And directly means one device does both of these things. For instance, a semiconductor laser that gets turned on with a big DC bias current, if my RF signal is fed onto that same input line using a bias T to separate off the DC, now I've got output optical intensity that's modulated by the RF signal. So that's direct amplitude modulation of the intensity. You could also, and in fact, the fact that diode lasers, when you modulate them directly, the optical frequency tends to move at least a little bit. This is the reason telecom people tend not to do direct modulation, is because they're trying to go long distances, and there is a little dispersion in the fiber, so if I'm moving the carrier around with my signal, I'm making things much worse for myself. The dispersion will cause that to be something that the detector sees as you move it around. Ordinarily, in a shorter link, you wouldn't try to exploit this because moving the optical frequency alone doesn't result in a change in optical intensity unless there is a dispersive medium or an optical filter. But there are these FM lasers that you can buy to try to get around that. It's just not very practical. So you don't